The Pyramid of Ancient Egypt and one of the most large-scale engineering structures of antiquity. Main parameters of this structure. Initial height to 146.6 meters. Volume. About 2.6 million meters. Number of blocks. Approximately 2.3 to 2.5 million. Average block weight to 2.5 T. Even with the use of tens of thousands of workers, the construction of such an object presents a serious logistical ch2. The problem of construction rates if we accept the most common estimates. 2.5 million blocks 25 years of construction, then the average laying rate is about 100,000 blocks per year, about 274 blocks per day, roughly 11 blocks per hour. Thus, one block had to be installed approximately every 56 minutes. Most existing hypotheses suggest the use of inclined ramps, sledges, levers. However, with such technologies, blocks were probably installed sequentially, which significantly reduces the possible. Therefore, it can be assumed that an effective construction system should have allowed for parallel installation of a L3. Main hypothesis. The proposed hypothesis is based on the use of an artificial reservoir created by a dam on the Nile. The following mechanism is assumed. A dam is built on the Nile. A large reservoir is formed near the Giza plateau. The construction site is completely submerged. The pyramid is built directly inside the reservoir. 4. Construction mechanism. Initial stage construction begins on dry land. A foundation and the first tier of the pyramid are created. After this, the reservoir begins to be filled. Main construction stage. As the pyramid grows, the water level gradually rises. This results in the water surface being approximately at the level of the current construction layer. Blocks can be delivered directly to the placement site. Thus, instead of lifting blocks upward, the water level is raised. 5. Transportation of building materials. The delivery of stone blocks could be carried out by water on barges and boats. The ancient Egyptians actively used river transport on the Nile River. It is known that granite blocks were delivered from Aswan, located about 900 kilometers from Giza. Therefore, the use of water transport in pyramid construction is technologically plausible. 6. Possibility of parallel construction. The presence of a reservoir around the pyramid allows for the assumption of simultaneous work by a large number. For example, 50,100 boats could be around the pyramid at the same time. Each boat delivers one block. In this case, dozens of blocks could be installed simultaneously in different parts of the structure. Significantly excel. 7. Using water as a construction level. The water surface has an important property. It is always horizontal. This allows it to be used as a natural level to control the height and horizontality of construction layers. Such a method could significantly increase the accuracy of masonry. 8. Geomorphological conditions. The Giza Plateau has the shape of a natural geological uplift, surrounded by higher areas. This makes it possible to create an artificial reservoir if a dam is present. Archaeological research has also revealed traces of water erosion. 9. Purpose of inclined shafts. Inside the Great Pyramid of Giza, there are narrow inclined shafts connecting the internal chambers with the outer sew. In traditional interpretations, they are considered astronomical landmarks, symbolic pots for the pharaoh's soul. Within this hypothesis, an engineering interpretation of their purpose is also possible. 9.1 Water drainage. If the pyramid was built inside a reservoir, then after construction completion, the reservoir had to be drained. After draining, some water could remain in the pores of limestone, in the gaps between blocks, in internal spaces. The inclined shafts could serve as drainage channels, allowing water to gradually flow out. 9.2 Drying the structure. After water removal, the shafts could provide natural ventilation, air movement, gradual drying of the masonry.